Hello. So this is Vinay Kashyap speaking, and I have completed the assignment that is a part of Coursera's Machine Learning Foundation for Product Managers. So I wanted to kind of share my assignment learning with you all. So speaking about the problem statement, in this project, the ask was to build a predictive model uh, so that we can predict the electrical energy output for a combined cycle power plant, which has the data of almost an hour worth of data from various sensors, including gas turbines, steam turbines, heat recovery, steam generators, and so on. So we have roughly around 9,500 plus, data parameters, which are primarily around the temperature, the relative humidity, the exhaust vacuum, the ambient pressure of the gas turbine, and also we, do have the energy output that was produced for, 1 hour. So in the table, I have kind of mentioned out all of those ones along with the range, in which we have the data from, for kind of, the understanding of the data and, the summary. So we have, the temperature, relative humidity, exhaust vacuum, and ambient pressure as independent variables, and energy output is a dependent variable based on, the first four parameters. So the objective here is to kind of figure out which machine learning model approach is needed, to kind of come up with the evaluations required to get the output metric, that is the energy output. So we have to determine which are the possible features that we want to consider, and which we want to drop. How do we split the data that we have, like roughly 9,500 data points that we have? How do we kind of utilize that to ensure that the system learns it, and it kind of gives its predictions. Uh, so that's the objective over here. So I did a quick check on the data quality, that we have, and I have used Python, by the way, to kind of do all of these activities. So the data quality checks, I was able to find out, the count to be, 9,568 for all of the, ones. So there was no data leakages, I would say. So considering that, it's good data set. So going ahead, the thought was to kind of figure out which are the, kind of figure out the feature data visualization, trying to figure out which has a good correlation compared to the inputs and the outputs. Meaning to say that, like for the output energy, which of the following, four input parameters, has a good correlation. So I try to do, a visualization of that by plotting, the input parameter, say temperature, against the energy output. And I was able to, see a very strong correlation between these two. And I did the same exercise for the rest of the four, where I kind of figured out that, there were, less correlation for relative humidity and ambient pressure, but there was some, level of correlation, I would say. I would say in terms of, like somewhere in the mid size, I would say, correlation for exhaust vacuum and energy output. So I was able to see some correlation on a holistic note, considering the temperature and the exhaust vacuum to the energy output, but not with the other two. So I also did the same exercise, trying to figure out the importance of the features using the random forest method, and I was able to see the same temperature, having a good correlation, when compared to the rest of the three. So I have picked, I mean, speaking about the parameters and model building, so I have picked the following parameters. The model building approach I have picked on the four, the linear regression, decision tree, random forest, and gradient boosting. So gradient boosting, I mean, boosting is a form of Ansible model, I would say. So yeah, so I've just picked that up. Speaking about the data, so I've picked 80% of the data, whatever was there in the data set for training and 20% for the testing. So the validation process, I have used mean absolute error and of course the accuracy. I've used Python platform and the features, like considering in the previous one, uh, the ones, the relative humidity and the ambient pressure having weak correlation, as per these two charts. I've tried to drop that, uh, considering that to be the least impactful features, and proceeded ahead with, the remaining two, that's the temperature and, the exhaust vacuum. So some of the, screenshots from the execution code that I have, I've just tried to do that. So here, I'm speaking about the models that I've picked. That is the linear regression, decision tree, random forest, and gradient boosting. So I've picked all of those ones. Evaluation of the of all of these four models. I've just, executed that over here and, stored those values. Tried to, get the first best model and the second best model of these four ones, and over here, I've tried to do some sort of testing, I would say, trying to figure out, the values for, each of those ones, trying to plot the values, I would say. And lastly, the visualization of the values, and whatever is the residual. So I've just tried to do that. I've added the screenshot just for, the screenshot of the code for just the first base model, but, I have the other one also kind of executed. Due to the real estate, I have not added that over here. So once I executed the model, so this is the final output that I received, where you can kind of see the MEA for linear regression decision tree. It's, in the higher note, 3.89 and 3.24 respectively, megawatt. But speaking about the random forest, so that is having the least one, that is 2.7, and the gradient boosting is around 3.17 megawatts. So speaking about the, the error, I would say the accuracy, that is the root square. The half square basically scores. So this is, 0.95, percent accurate, and this is 0.94, percent accurate. So considering, the MEA to be the least one and the accuracy to be the highest, the random forest is the best model that, we can pick up for this particular scenario. And the next best, I would say, is the gradient boosting. So I've tried to kind of do, a quick, visualization of the data, considering the actual values and the predicted values. So you can kind of see the random forest that is in blue over here. It kind of fits in, almost nicely, I would say, to the actual values, and the predicted value kind of fits in, I would say, kind of perfectly. And even, the distribution of the residual, it kind of goes well in hand, I would say. Speaking the same from the gradient boosting model as well, it kind of goes well, but, there is comparatively, like I can say slight changes, but, it's almost the same. And the same thing, with the distribution of the residual too. So it kind of neatly fits in. So here are some of the sample output records, and I've tried to put it considering just the temperature and exhaust vacuum, and the energy output, which is the actual value that's been provided in the CSV file. So here you can see the random forest predicted value and the gradient boosting predicted value. So you can kind of see over here for the first row, it was 455.27, and here for the random forest predicted it to be 454.784, and the other one kind of predicted that to be 453.9866. So, and, like you can kind of see that, the values for the rest of the ones are almost nearly matching as well. So conclusion, compared four different models, and kind of figured out that the random forest and the gradient boosting, are the two best models that we can use for this particular one, considering the higher accuracy and lowest MEA value. So the values I've kind of mentioned that over here. And lastly, the temperature is the most correlated feature to the energy output, and followed by that, the exhaust vacuum has come somewhere closer, I would say. But the relative humidity and ambient pressure, they do not have any sort of correlation. Thank you.